Today we're going to learn about polygons. The first thing you need to know on the chart that you're going to be filling out is all of these are regular polygons we're dealing with. When I talk polygons, I mean a three-sided enclosed figure that is hollow on the inside and no curved sides. All sides are considered to be straight without any curves. Okay? The reason these have to be regular polygons is when you start to solve for each interior angle measure and each exterior angle measure, the only way you can calculate these is if it's a regular polygon. Because if it's not regular, then all the angles would not be the same. Because a regular polygon means that all angles are congruent and all sides are congruent. So we're going to start by looking at our chart and filling in what we do know. What we do know is we start with the smallest of your polygons, the three-sided figure one, which is called a triangle. Your four-sided is a quadrilateral. Your five-sided is a pentagon. 6 hexagon. 7 heptagon. 8 octagon. And 9 nonagon. At the end of your chart, once we fill out all of this chart, you're going to look for your patterns in order to get your last row, which is when your sides are in, meaning these will be formulas with the variable n in them. So let's take a look at the first two polygons. A three-sided polygon, regular three-sided polygon, is a triangle whose all three sides are the same, all three angles are the same. It's named a triangle. Now, in order to find my triangles formed by diagonals, I have to draw in my diagonals. But if I look here, if I start at one vertice, this is the only vertice I can start from, and draw diagonals to other vertices that don't make a side of the polygon, I can't draw any diagonals on this one because the other two are vertices. The other two vertices would cause them to be the sides of the triangle. So I can't draw any diagonals, but I do have one triangle in the figure. Okay? And we know that one triangle, the measures of the angles in a triangle always add up to 180. So my interior angle sum is 180. To get to the interior angle measure, I know that all three of those angles add up to 180. I also know that all three of those angles are exactly the same. So if I divide the interior angle sum by the number of angles, 3, I will get that each interior angle is 60 degrees because this is a regular triangle, meaning all the sides are the same and all the angles are the same. To get your exterior measure, if you look down here where I've drawn this triangle, the 60 degrees is on the inside of your triangle. The angle on the outside of it, right by it, makes a linear pair, meaning they should add to 180. So if I do 180 minus 60, I would get that each exterior angle measure should be 120. Then, to get the sum of your exterior angles, you multiply that by how many exterior angles you would make, which is the same number as the number of sides. So that would be 360, 120 times 3. Okay? So if we look at a quadrilateral, we're going to do the same process. 4 sides. Here's the picture of it. It's a quadrilateral. How many triangles can I form by my diagonals? Again, I start at one vertice. That's the only vertice I can draw diagonals from. I can draw one straight across to this vertice, and it's not making a side of my quadrilateral. So that means one diagonal, but how many triangles did it form? 2. 1, 2. Okay? Now, if I know each triangle is 180 degrees, and this has 2 triangles in it, I know that the sum of my interior angles would have to be 2 times 180, because there's 2 triangles at 180 degrees each, and that would give me 360 degrees total for the interior angles. Again, I know that all 4 of those interior angles are the same, so I divide by 4, and I get that each interior angle is 90 degrees. If my interior angle is 90 degrees, then my exterior would also be 90 because 180 minus 90 is 90. Then, to get the sum, 90 times 4 is 360. Alright, now, if you're already trying to look for patterns, there's one that should be staring you right in the face, and that's your exterior angle sum. If you notice, even on just 3 and 4, we ended up with the same number. Well, let me tell you, that is correct. And it doesn't matter how many sides your polygon has, it's always, your exterior angles will always, always, always add up to 360 degrees. So, you can go back on your chart and just put 360 all the way down. Okay? Now, to get your formula for each exterior angle, remember, we're doing this in reference to the number of sides. So if I know that the sum of my exterior angles is always 360, I can get my exterior angle measure for one exterior angle, if it's a regular polygon, by just simply dividing that 360 by n, the number of sides. So there is my formula. Okay, now you should be able to fill out the rest of this chart on your own. And then if you have questions still on what the formulas, the last 3 formulas are, please come and see me.